Okay, here's some problems from Chapter 1, Section 1. Hopefully these are review, but maybe these will be good for some other people to take a look at too. The first thing we're to do is to find the slope of a line that passes through two given points. And we often refer to slope as rise over run. And the rise, of course, anything that's a rise is a change from a y. We change from a y value down here to a y value up here. As we run, that's a change of the x's. So for instance, on this line, we have a rise that we divide by run and set up our fraction, which is our slope. So if our rise is the top of our fraction, then we want to know how much our y distance changes. That is a y value minus a y value. 4 minus -4. And our run, the change in run, is the change in the x values. Excuse me. Over 2 minus 4, so we get 8 on -2, or our slope is 4. Simple, but surprisingly frequently missed by students even at high level, such as honors pre-calculus. So let's be careful with that one. That's really a foundational, that's not one of the things that we can just afford to be pretty good at. We have to be 100% on that because so many problems rely on it. Okay, line passes through a given point and has a given slope. Find 3 additional points that the line passes through. We could, of course, if we had some graph paper, we're willing to sketch this, we could plot the first point, -1, 2, 3, 4, 5, and up 1, 2, 3, 4, and we could plot that point. And then we could build our graph by running with a slope of 2 or 2 over 1, and that, of course, is rise over run. So we could rise up 2 points, and we could run, or 2 spots, run 1 spot, and we could create a new point, and we could come up with the coordinates with that. But I think we can do that without the aid of a graph. If we realize our current height, 4, to get to the next point, if we rise 2, we go from 4 up to 6. If we run 1 or increase, move to the right 1, we move from -5 to -4. And a second point, let's just continue that process. From 6, we rise 2 to 8. From -4, 1 to the right, we run 1 to the right, -3. Rise 2 from 8, 10. Run 1 to the right, from -3, -2. So there's 3 points. Of course, we could do that backwards as well, because 2 over the 1 is the same as -2 over -1. So we could have risen -1 from 4, which is actually a fall of 2, down to 2. Run -1 from 5, or move to the left to -6. So obviously our answers could vary on this, but use a graph if you need to, but kind of nice to think through without the aid of the graph. Okay, we're to find the slope and y-intercept of the line 2x plus 3y minus 9 equals 0. This is given in general form. It's not perhaps a form we'll use very often, but it's nice to be able to communicate that. So it's in general form. We're to find the slope and y-intercept, but we know if we can put this in slope-intercept form, we'll have our slope and y-intercept. The slope-intercept form, oftentimes when I'm teaching this to maybe an Algebra 1 class, um, I'll, I'll talk about slope-intercept. Slope starts with S. S stands for solve for y. So we're going to solve this guy for y. So I'm going to leave 3y on the left side of the equation. I'm going to subtract 2x on both sides of the equation. And I'm going to add 9 to both sides of the equation and finish with division by 3. Divide the entire both sides by 3. Y is -2/3 x plus 3, so we have a slope of negative 2/3, and we have a y-intercept of 3. Again, perhaps a little bit insulting if you're in honors pre-calculus right now, but things that we just cannot afford to be pretty good at. Being pretty good at this is going to result in being pretty much a struggling honors pre-calculus student. We really have to nail this every time. So here we are back to general form, which we just talked about. And general form, it can be written as ax plus by plus a constant c is 0. And typically we would say a should not be negative. And typically we do not write this with fractions. So I'm going to go ahead, since they give us a point and they give us a slope, I'm going to use point slope form, which is y minus something equals m times x minus something. And I just call point slope form puzzle pieces. P for, excuse me, point slope form. I call point slope form puzzle pieces. P from point slope, puzzle pieces. P. So what goes with the y is the y coordinate, negative 5. What goes with the x is the x coordinate, negative 2, and the slope, of course, fits right in here. Those are our little puzzle pieces we put in place. So if we want general form, one of the things is we don't want fractions, and I see we're going to have a fraction here. I'm going to go ahead and plus positive, plus positive. So I'm going to multiply both sides by 4. And the left side becomes 4y plus 20. Now we all know I basically on the right side have 1, 2, 3 numbers being multiplied together. And if I had, say, 2 times 3 times 5, we all at this time certainly know we can multiply numbers in any order. No matter what order I multiply these numbers in, I'm going to get 30. So I'm going to choose to multiply 4 times 3/4. And I get 3 times x plus 2 when the 4's cancel. And 4y, excuse me, 4y plus 20 is 3x plus 6. And ultimately, I want to get everything to one side, but I note I want a to be positive. So my number in front of x should be positive. So I'm going to leave 3x. I'm going to leave 6. Let's come back to that. I am going to leave 6, but I'm going to go ahead and subtract my 4y's over here. I'm going to leave 6 and subtract 20 on both sides, minus 14, and that is 0. So there is our general form. One thing we often will do as well and check at the end, and we should be in pretty good shape on this, normally in general form we wouldn't have anything that would reduce. So if, for instance, this term was a 6, I would then divide both sides by 2. Okay, slope intercept form. Y equals mx plus b. This may be most of our viewers' specialty equation. We use this one quite a bit. Equation, the line that passes through these 2 points. So we certainly need slope, and slope again is rise over run. Rise is how much the y's change. Y's change from 3 to negative 4. Over run, how much the x's change. X's change from 4 to negative 4, and we get 7/8. And at this time, you have options. You can go right into the y equals mx plus b, but since I've got a point and a slope, I'm going to go to point slope form. Y minus the y coordinate equals slope times x minus the x coordinate. And I want to solve this for y, so I am going to go ahead and distribute the 7/8. 7/8 x minus, when I distribute 7/8 to 4, the 4 and 8, the 4 reduces the 8 to 2, so minus 7/2. And we're close. Add 3 to both sides. 7/8 x, I have minus 7 halves plus 3, or minus 7 halves plus 6 halves minus 1 half. So there we have it. And 54, this is again from section 1.1. State whether the line that passes through 2 points is parallel, perpendicular, or neither. So to review, if two lines are parallel, their slopes will be equal. If they're perpendicular, then their slopes are opposite reciprocals, and otherwise they're neither. So this is a study of slopes. So I'm going to find two different slopes. Slope of the first line I'll call slope 1. Y's change from -1 to 5 as x's change from -2 to 1, giving me -6 on -3, or 2. And then slope 2, the y's change from 3 to -5 as the x changes from 1 to 5, giving me +8 on -4, or -2. So our slopes are not equal. They are opposites, 2 and -2, but they are not reciprocals. Therefore, they are neither parallel nor perpendicular. So I hope that helps. Make certain you have this work completed if you are working along with us. If you're just viewing, you're not a part of this class, I hope this was helpful to you as well. Stay tuned to Purple Shirted Nerd. There may be a lot of things on this channel that end up being helpful to you. Thank you very much.